All right. Hello, my name is Thomas Stanley. I work for the University of Maryland, Baltimore County at Goddard Space Flight Center. I'm going to talk about LHSA, its historical context, and what it offers. LHSA stands for Landslide Hazard Assessment for Situational Awareness. It tells us about rainfall-triggered landslides at the geographic scale, but not other hazards such as riverbank collapses or rockfalls. I'm going to talk about the history of LHSA, the global data it uses, the machine learning approach we take, and a little bit about the global exposure analysis we do at Goddard, which is different from what PDC makes available in Disaster Aware. I won't be talking about post-fire debris flows, but there has been work on that as well. Central America has a leading role in the development of LHSA. In 1998, Hurricane Mitch impacted the region, causing a great deal of damage. At the time, researchers at Goddard were able to estimate rainfall with data from the Tropical Rainfall Measuring Mission, but did not have a good way to share that information with stakeholders. Over subsequent years, they developed a near real-time global landslide hazard assessment that used a susceptibility map and satellite rainfall data. Then a regionalized version of this model was developed for Central America. Soon after, we developed a new model for the Caribbean region with the goal of transferring it to regional stakeholders. This is the work I was hired to do when I first arrived at Goddard. It's also the first time we used the term LHSA. Then we based the global LHSA model on this regional approach. This is the version that probably most people are familiar with. In 2020, we started running a new version of the global model, which replaced the heuristic decision tree with machine learning. We also added an exposure module to better show the potential impact to humans. Soon afterwards, we added a forecast mode to the near real-time outputs from satellite precipitation and a module to assess the hazard of debris flows in burned areas. We also made a regionalized version of LHSA for the lower Mekong region, again as part of the Surveyor program. So now that you know the history, let's look at how the current global landslide nowcast works. In LHSA 2.0, we bring in variables for snow and soil moisture from the global data assimilated level 4 product known as SMAP L4. This product is available with a latency of 3 days, so we fill in the gap between the current day's rainfall and the prior period with 2 days of antecedent rainfall. Now, you might ask, how are these different variables weighted? We'll get to that very soon, but let's look at the data more closely. Let's start with rainfall. The global LHSA model relies on the Global Precipitation Measurement Mission, or GPM, to tell us where in the world we can find the most intense rainfall at any time. NASA's GPM Core Observatory has both dual frequency precipitation radar and a multi-channel microwave imager. These give us both a broad swath of data and a detailed 3D map of storms. However, this isn't the only precipitation satellite. GPM is one satellite from an international constellation of satellites that provide improved space and time coverage of precipitation over the globe. The readings from all of these satellites are harmonized and put into a single global estimate of precipitation rates with a 30-minute resolution, and that product is called iMerge. iMerge is currently being upgraded from version 6 to version 7 right now. SMAP L4 combines recent satellite measurements, shown here, with a hydrologic model to produce dynamic maps of soil moisture and other variables. The process of merging these different types of information is known as data assimilation. Because SMAP, which stands for Soil Moisture Active Passive, was launched in 2015, we can run a hindcast from the spring of that year to the present. LASA 2.0 also uses some of the same variables as earlier versions, but not in the form of a susceptibility map. Instead, these variables are treated separately by the model as factors that affect the impact of the current rainfall. A global lithologic rating was created by identifying the areas with steep terrain and ranking generalized lithologic types by the average steepness within regions of high relief. Since this is a general global assessment of rock strength, it is likely that a more specific assessment would produce better results at the national scale. For this variable, the slope angle was first calculated at a 90-meter resolution from the Viewfinder Panorama's digital elevation model. Then the data set was aggregated to a resolution of roughly 1 kilometer with the maximum function to ensure that no potentially hazardous location was omitted. LASA 2.0 is reliant on landslide inventories for both model validation and training. Nearly 100,000 individual landslides were used to train the model. However, once these were gridded to the model resolution, less than 10,000 independent data points remained. In order to define the empirical relationship between landslide occurrence and its predictors, we used a machine learning library called XGBoost. XGBoost uses an iterative process to fit the training data by building one tree at a time. Each subsequent tree corrects the errors of the existing model. On the right is an example of one tree created by XGBoost. This shows current daily rainfall modulated by either antecedent rainfall or the distance to the nearest fault. Depending on the numerical values of each predictor, one of the 4 leaf values at right will be returned. Remember that this is just one tree out of 300, so the final output would be only weakly influenced by the calculation shown here. We can also understand the model as a whole by calculating 3 metrics: gain, coverage, and frequency. Each of these reveals some aspect of how the model treats all the variables. In some cases, the model might not use a variable at all. In fact, this happened multiple times during the development of LASA 2.0. LASA outputs a map with an estimated probability of landslide occurrence for each square kilometer of land surface. Due to the nature of the training data set, it's better to think of these values as a hazard ranking rather than a definite probability. Next, the hazard map is compared to global maps of population and roads to produce near real-time exposure maps for every county. The same process is repeated with forecasted precipitation from the GEOS FP global forecast product, replacing iMerge and SMAP-L4. The LASA model remains unchanged, as do the static variables. These forecasts offer a window into current and future conditions. So to review, we divided rainfall into a 1-day current rainfall and a 2-day accumulation of antecedent rainfall. Soil moisture comes from the SMAP satellite. We combined all the different predictors using a tree-based machine learning model. And we're very much reliant on the landslide inventories that we have access to for both developing the model and testing it. And if you get nothing else from this talk, know that pretty much everything I've mentioned is open and freely available at no cost to you. And so you can take pieces of our approach and apply them in your context, even if you don't want to adopt the LASA 2.0 framework. There are a number of directions I'd like to take LASA, but stakeholder feedback is important to prioritizing the potential improvements. One important piece of feedback has been that the data feed needs to be really robust. One way to achieve this might be to build an ensemble of models that take in additional data sets from NOAA or other institutions. But I encourage you to contact us here at Goddard and let us know by email or other means what you're interested in, and perhaps we can consider that as well. Here are some papers where you can learn more about LASA. That's all I have. Thank you.
Oh, thank you, Thomas, for the great presentation. I think we have a short time for questions if you have questions. Just feel free to open the microphone and make a question if you have. Okay, hearing none, I would like to, we have Mario. Mario, you have a question? No, I don't think so. Okay, yeah, Michelle has a question. Go ahead.
Yeah, maybe. Thank you very much, Thomas, for the presentation. I saw in one of your slides when you were showing us a table with the variables that you are using. Of course, that was just an example, but it emerged to me that the soil wetness was not so important in the prediction. Is that typical, or is it like in that slide? I mean, what is the role of soil wetness in your model?
Well, the summary that you get there is I think accurately describes our model. The soil wetness is not a strong predictor. I think you have to keep in mind that this is in the context of knowing what the current and antecedent rainfall are. So the wetness is from 3 days before. It's essentially an antecedent condition, and therefore it tells you like how wet the soil is 3 days ago. But of course, what we want to know for predicting landslides is what the groundwater is doing instantaneously rather than 3 days ago. And so the current daily rainfall tells you more about what the current state of the groundwater is rather than soil moisture from 3 days ago. So I think that's the primary explanation for why soil moisture is not weighted more highly. It's not a model, we're not running a global real-time hydrologic model that's telling you what the water table is, how it's going up and down in every location. And so as a result, we're not, that variable is just, it's just influencing how the soil responds to the current level of precipitation. I also see a question from Yuri. I will respond in the chat. So I'll talk about that. How to get the question is how to get the training data sets. The short answer is you can go to landslides.nasa.gov to see the data we trained with, but I will respond in more detail in the chat.
Yeah, also we have a question from Jeff. Go ahead, Jeff.
Hello, I have a question. How it is possible to obtain that information from the satellite, because the resolution it has low resolution. However, the landslide have a little area. How you can get more information in the landslide when they have a small area with a small resolution with the satellite? Thank you.
Sure. So in what we're doing here is predicting where landslides are probable. And essentially we're taking a statistical approach. So we're not actually, these products are not telling us exactly where landslides are, only where landslides are highly probable. And therefore, the course resolution inputs may not tell you with absolute certainty which 30 meter or which 1 meter location, with a 1 meter resolution, where the landslide will go. It doesn't answer that question really, but it does allow you with kind of a statistical level of certainty to know that certain areas are more hazardous than others. So like I mentioned earlier, I would really consider this product more of a ranking than an exact map of where every landslide is going to be. I don't think you should use it in that context. And so if you want to know where the landslides are with absolute precision, you have to wait until after they happen and then fly a drone or something to find out where they go.
Thank you. Thank you.
Sure.
Right, thank you. I think now we can move to the other presentation. Thank you, Greg. Happy for being here. Greg is part of the Pacific Disaster Center. I think this has been a cooperation between NASA and Pacific Disaster Center from several years. Finally, around a couple of years ago, they published this application for disaster aware. Go ahead, Greg. Thank you for being here, and the floor is yours.
Okay, thank you so much. I'm going to try and share my screen now.
Go ahead.
If I can. Give me one moment.
Yeah, it's okay. Good
Okay.
mode, presentation mode. Okay, thank you.
Thanks. Thank you. So my name is Greg Hampe. I work with the Pacific Disaster Center. For anyone who's not familiar with the center, I'd like to just give a quick background on what we do. We are managed by the University of Hawaii, so we're a research project out of there, a research center. We've been in business now for about 28 years, and lots of partner projects and lots of hardware and experience going around the world with lots of other partners as we kind of learn what they're really looking for on the ground. We've worked with some agencies here in the U.S., also some international agencies and organizations, as well as some other national governments. And we're fairly open to just working with whichever groups are looking to collaborate and cooperate. And it's been, again, that experience that sort of helped us to what we present to make that useful to our folks. Our main mission is an evidence-based research and to promote risk reduction, humanitarian assistance, disaster relief, and really on the ground disaster management tools that are helping people. We've got what we think of as an integrated approach. We pull in a lot of data, and in most cases, we were pulling in data or advisories or notifications and adding it to other data that we had, including populations, some historical risk affected demographics, and those kinds of things, to try and pull several threads together. Working with LASA in particular has been sort of a new experience where we're really working with them from the beginning of creating an integrated display of the landslides. Our main system is disaster aware. It shows hazards. We have some products that it also produces, including Event Brief. We have a smart alerting capability that users of our system can actually be alerted for areas or hazard types that they care about most. Some capabilities now with some of our systems on asset protection and cameras that are displayed for where available. We have about 28 different types of hazards. I'll show you as soon as we get into the system, you'll see more of these. But we have both natural occurring hazards and what we call geopolitical hazards or man-made hazards, conflicts and other things. Our focus, especially today, is on what has turned out to be a very, very fruitful partnership working with the NASA teams, their global flood team, and LASA. And we've also brought in, obviously, lots of other NASA data. I'm not going to worry too much about flood today. I'm going to focus on landslide. Here's where we're going to just pick up from where Thomas left off. So we've taken the LASA system and installed it so that we have an instance. As Thomas mentioned, this is readily available so that people can download and run this system. So we have it running on a hosted server. It pulls in the data that Thomas already mentioned, We bring that data in and start to turn it into the things that we need, including a probability layer. We then take that information that is output in that geo information and start grouping things into what we call incidents. And then at certain thresholds, those incidents can become a hazard. We create those hazards then, which think of it as an entity, a self-contained entity, and start to interface that with some other things such as potential exposure to populations, and develop products automatically coming off of that. And all of that winds up getting displayed up on our system. So as we mentioned, the source is LASA. This is our primary, our sole source for the landslide information. We have other things that help us with some of the impacts, but as far as the landslide hazards, our sole source is the LASA model. Some things that we've done is as part of our collaboration is intersecting that LASA information, for instance, with known mountain ranges, so that where we see some potential false positives that occur out on plains that would not really be indicators of landslide, but may have the other factors that might bring them up into the LASA layer. We eliminate those. We're really only looking at things that intersect with the topography that would promote a landslide. From there, we're also, as we said, doing some grouping, but also some thresholding, including getting to certain severities in order to present those landslides. Once we present them as an actual hazard, the things that we add in, as I mentioned, the severity, and we have warning, watch, and I apologize. I'm sorry, just warning and watch. We don't do advisory hazards for landslide. I was trying to remember really quickly. So we also generate a description based on the information we've got, give the hazard a name, sort of a useful name that may align with the surrounding population so that people would actually have a good sense of where that region might be. And what you can see down here is a report that's generated as well, including population that might be exposed, as well as, in this case, some infrastructure of bridges or dams. This is similar to what we did earlier in our collaboration on floods. And you can see some of the a similar type of situational awareness product here and similar kinds of severities. Our goal here, of course, is to try and give disaster managers a sort of a uniform set of information about hazards across the many types of hazards. I'm going to go ahead and move past this and on into our last one, which is we also use some LASA data for wildfire. Thomas had mentioned post-fire debris flow. As you can kind of imagine, down the road, these hazards right now tend to be thought of separately, but we're seeing more and more how they interact. And so our history of wildfire may start to contribute as well to predictions of other types of hazards and further effects of flood as we start to see these hazards interact with each other. Event Brief is one of the products, is our latest product that it now produces, giving a much more detailed snapshot of what that hazard may present. And we can see that again on the system live, but here's an example of a landslide, its exposure area, the population that might be expected, and then a breakdown even of needs of that population. These are all automatically generated based on demographics, population density, known standards for needs within a disaster, and other such sort of disaster management standards and practices. And then last on, I think, our slides before we can get into the actual demonstration, we have what we call Smart Alert. And in setting up a Smart Alert for a user, that user's is able then to choose which hazards they want to be notified for, which levels of the hazards, and also create a geographic boundary for where the hazards that they are concerned about would be. So therefore, a hazard falling within that geographic area of a specified type at a specified severity, they would get notified. It allows you then to not be pinged constantly by everything going on around the world. We reserve that just for the people who work here. We're the ones who get to see everything coming through multiple times every few minutes. But that can be fairly disconcerting for most users that aren't running the system. Also, just as a note, we have a public-facing system called Disaster Alert that doesn't require a login. We have about 3 million users that make use of that. We have Disaster Aware Pro, which is for both nonprofit and disaster managers, state and local and national disaster management, as well as other private sector users. There we have tens of thousands of users on that one. And we also have a downloadable app that has much of the same functionality for smartphone use. All right, I'm going to go on into the system. So first, there we go. Can you confirm that you're now seeing the live system?
I can see it.
Yeah, yes.
Excellent. Okay.
Greg,
Yes.
1 second. Yeah,
Sure.
I would like to make a brief summary for some people who doesn't speak English here, because this is the important part. Ahora vamos a entrar en el demo. La aplicación se llama Disaster Aware, está en el Pacific Disaster Center aplicación, es una de las aplicaciones principales. Y aquí ustedes podrían tener un usuario y poder acceder a estas características de la plataforma para ver cómo se despliega el resultado del modelo de deslizamientos de NASA dentro de Disaster Aware. Entonces, ahorita lo que va a mostrar Greg es esto, y ya más adelante vamos a indicarles cómo pueden crear una cuenta y cómo pueden pedir una cuenta gratuita para entrar en el sistema. Lo voy a dejar ahí. Thank you, Greg. Yeah, please continue.
Thank you. So for this part of it, I'm going to make use of some functionality of the system and kind of walk through it. But I am very happy to make this interactive. So if there are questions along the way or things that you'd like to see or things we'd like to zoom in on a little bit more, that's fine. I only ask that since I'm looking at the screen, I won't necessarily be able to catch it if a question pops up. So please just go ahead and speak out, or if the moderator wants to just let me know, we can focus in on issues of interest.
Okay, sounds good. Thank you.
So I'm going to go ahead and I'm able to change the views and the backgrounds just because it is built on a platform that's got a lot of GIS components. It is primarily the GIS visualization of disaster data. So what we're really taking is, with all of these different disaster types, defining an area, defining a severity, and then the critical information that's going to be presented with it. As mentioned, our basic purpose for the system itself, early warning, being able to monitor multiple hazards all at once, and looking in terms of operational response and recovery for disasters or for hazards that may be affecting your area. Risk assessment, mitigation, because some of these hazards represent risks that haven't actually happened yet. They are of a great possibility. And think in terms of hurricanes that spend days and days approaching until you finally make landfall. During all that time, you're watching and sort of planning out what the possible effect may be. We've got a lot of different features in the system, some of which I've already mentioned. But once into the system, there are other layers that can be brought up and ways to sort of analyze and things. So the system itself does have a multi-layered approach. That first shot of just it being kind of a dashboard to show you what's going on is kind of its initial thought. But I have a lot of different layers I can bring in and layers that I can create that can help make both a disaster that's underway or analysis of previous disasters useful. For the disasters that we have, you can see this is our list of current natural disasters, and with only a handful of exceptions, all of these are automated, meaning they are generated in real time as the data arrives throughout the day. For landslides, we have a LASA run 3 times a day, so every 8 hours, the LASA data is updated. Therefore, the LASA hazards are updated. Some expire, new ones might be created. We also have, as I mentioned, some geopolitical hazards, such as some civil unrest, combat, things that might be assumed to impact disaster responses or make a disaster that much more complex for lots of regions around the world. With that, I'm going to move on in to see if I can get to the landslides. Actually, I have better ones over in Papua New Guinea. There we go. So this is a live hazard. As of 5 hours ago, LASA put out data that indicated likelihood of landslide across this area. As you can see, it's a fairly large area. I'm going to go ahead and take some of these layers out. What you can see around it is the iMerge rainfall. This is one of the key components that Thomas mentioned in the LASA system. Moving those out of the way, I get a better view of the land and area that's being affected. What you can see now is the actual landslide extent, and what you're seeing, and I want to make sure that I'm yeah, good. So the probabilities that I'm seeing where it's red, it's the highest of probabilities. What you can also see is pixels within there where we've got some lower probabilities all the way down to yellow and pale yellow. We include all of those in what we think of as a cohesive form. This has got some buffering to it, but generally speaking, this is the whole area that's covered within this because it's contiguous. But it's the red areas that make this rise to the level of being a hazard. If it were at the, so that makes it at a warning level. If we're at the watch level, it would require a larger area. This might actually be sufficient in this case, but it would require a larger area that would show enough probability over an expanse that would say that there's a decent likelihood of landslide in that area. Now, this doesn't predict that there will be a landslide, but what you can also see is in looking just at this region, if I'm concerned about landslide in that area, this is basically indicating this is where you would want to be looking. And if you're going to pre-position any disaster response or such, that these are the areas you're going to be looking at. And in that way, what it does is it gives you a heads up. Now it does this. I'm going to actually take one of the things Disaster Aware will let me do is filter on one hazard. I can take all of these hazards and get rid of everything other than the landslides. So now I've got just a global view of the last LASA output and where it's indicating there's probability of landslide activity. And with that, I can zoom on in. And with the fact that we've broken it down by levels of probability, I get a more informative view of what possible landslide activity might occur. And again, what is the main takeaway, I think, from the LASA system is going from a global area where you've got history of landslides and pulling it down to a set of factors that say, in this current, 24-hour period, these are the ones that bubble up the most to likely landslide activity. I'm going to pause just to see if there's any questions that anyone might have about this while I've got this area. My next step will be diving in a little bit more into the hazard itself.
And let me see if we have questions. If you have questions, please raise a hand. I have a question, Greg. What is the level of trust at country levels? Because in some countries could be, we have less trust in some countries.
The in terms of the country's trust in us or our trust in the country?
No, the model.
Oh, of the model.
Is reflecting the right events, because sometimes you have false positives.
Well, we're definitely going to have, we'll have indicators of these. What we would expect is there might be 1 or 2 landslides that may actually occur. But what we're seeing here are all of the ones that are essentially of the highest severity, all having equal probability. Which ones will occur, we don't know. But what we do know is there should be a high degree of trust that these are the areas that are most likely. But as Thomas said, the only way to truly predict or to truly have a concrete piece of information is to actually observe it after it happens. So this is where we see most likely. In some ways, I'm more concerned about false negatives, that a landslide occurs somewhere where we had no indicator.
All right.
So one of the things we do try and do, though, is we've got, these are grouped up and then are created into hazards. But the fact is, I could take off the hazards themselves, and I could just display that LASA layer, and that would still be informative, because I'm going to include all of the information, even the ones that didn't rise to that level of hazard. That layer is always available. So what we then do is, by showing our work and trying to be very transparent, we say, based on all of this, we see hazards most likely in these 3 spots. And if I go in to this one, for instance, and click on it, it will, it's going to zoom in more on this one. If I probably have a little bit of latent data there, which is why it's not extending all the way up. But generally speaking, you can see these groupings. I wouldn't expect there to be a hazard here because I don't really have the threshold. I've got some high severity pixels, but these are actually quite small. I need enough of them to really give me the weight to say that that's something we would call a hazard. But as we said, again, we still display it.
Thank you, Greg. I think we have a question from Virgilio.
Yes.
Virgilio.
Okay, thank you. Thanks a lot, Greg and Ricardo. I have a question. Is there a way to add some local geographic, how do you call that? Our information, geographic information from our country? Okay. Yeah, I mean, because we have some services, some WMSs and WFSs, and maybe we can add them to the service. I'm not sure if they can be used in as in the LHASS process
Right.
yet, but there could be a way to show them at least and make them part of the application.
Oh, absolutely. There's several different ways to do that. For instance, I can add some user layers. If in my instance, if ever, where I'm doing it, if I'm the person who's running this for my particular area, my municipality or my region, I can add some additional user layers just as a user and create some analysis that I want to share. We also have, in some countries, we've got their own instance of disaster aware. It receives all of these hazards from us, but it's really their own instance that allows them to add many more layers and other things that they want to put into it. And then sort of lastly, if there is data, whether it's regional or global, that might be very useful in terms of looking at that. There's ways to bring that data in as a layer or as products. And I'll give you one last one, which is if, say, for instance, once you've had a landslide and you've got you're actually doing some actions on it, what you'll see here is under this landslide, for instance, I've got, I don't have any products. Well, I don't have any products. Give me 1 second here. I'm going to go to this guy and see if, there we go. So I've got a map product here, but simply sending a other data in the form of like a product or a sheet, any kind of data, it's easy for our folks to go ahead and add that to a hazard, especially if one's going on. And so that it starts to gather up in that folder. So as I said, several different ways to bring it in. And depending on what you're looking for, those can be explored and we can figure out what best works either at a local level or global.
Yes, just going on with your answer, we do have information to add on to what you guys, because I mean we don't use exactly everything you put in the system, because but we do use it because usually it has the resolution is bigger than we usually have at the country level. We're a small country, yeah. So we use it as a way to see what happens around the world, and that's fine. But when we have if you go to Ecuador right now, you'll see that there's a marker for well, you don't have landslides over there, but we had like 3 or 4 landslides in the last days, but they are smaller. We had a big landslide in Quito last week that happened in an urban space, and you also have over there, you will see 2 volcanoes and a flood warning for Ecuador. So what I want to, yes.
Oh, I'm sorry. Go ahead. I was just going to say I brought up landslides for the last, I think, 5 or 6 days.
Yes.
Yes. And I think we see a lot more activity.
So that's fine. So what I wanted to tell you is that I would like to bring information from our side, from our records, for you guys to work on, because the products you have over there, all the PDCs, information charts and all that, they're amazing. But usually they don't show the information we have on our register and under our databases. So I know that's a lot to work on, and I just want you guys to know that we've been trying to work together for a while, and I was expecting for you guys to come here in April, but I was told you were coming in maybe September, August. So
who are you working with?
Let me see.
Is that Alex?
Alex, yeah. My guess is it's Alex, yeah.
Okay. Please, if the appointment's got my email address, you may already be in
Alex
contact
Caria.
with Alex, but
Yeah,
don't
Alex Caria.
hesitate to send me something, and I can go ahead and loop him in as well.
Greg, if I could jump in
Yeah,
for
okay,
a
that's
second.
Sure.
I
I do
just
want to
wanted
make sure I get to Graziella though.
Yeah, I'll just be quick. I just wanted to say, like, to Virgilio and anybody else who has information on the timing of landslides, that's really invaluable for future updates to the LASA model. So previously we did have a data set from Ecuador that was like open and published on the web, but you probably have access to better information. And so just feel free to send me an email and discuss what you are willing to share, and we would be very happy to have it, I think. That's all. Carry on, Greg.
No,
Amazing. Thanks a
thank
lot.
you, Thomas. I almost was going to offer you up because I know that the historical data is extremely valuable on your side, in particular.
Thank you, Greg. We
sure
have a
thing.
Graziella
Yes,
question.
hi, Graziella. How are you?
Yeah, thank you very much. Now, I remember that some years ago there was some limitation in the northern latitude with the LASA data. How is the status now? Because since I am in Norway, so
I anticipate that we probably have similar information, and I think Thomas, is that because of an iMerge limitation?
Let me answer that. So
absolutely. In
previous years, we actually only had the satellite precipitation product only went up to 50 degrees north, so it didn't cover Norway at all. Currently, iMerge actually goes pole to pole now. There are some reasons why currently we're producing a product only up to 60 degrees north, and I won't go into those now, but we can talk after the presentation if you want. But in any case, the product is currently available up to 60 degrees north, which, you know, gets you to southern Scandinavia.
okay.
I think we could run we have the potential to run it further out. In terms of like model accuracy, I would note that it used to be the case that it didn't do very well in northern regions, and partly because we didn't include snow explicitly in the model. But now we do include snow. So in the northwestern United States, where snow is a very important factor, we're actually doing better than we used to. So as far as the accuracy goes, I think it's better. In terms of the service area, it still stops at 60 north. So, you know, much of Norway is not affected.
Yeah, thank you.
I was just looking just to see historically, just in the last month or so, how far north they've gotten.
No, we had a big event in August, but I don't know if it did go very back to that.
So I'm going to just zoom in now on this one, and you can see it sets up the exposure area, basically an aggregation of the different levels of LASA from the LASA signal. I've got an auto-generated description, but I also have in here, this is what we call a hazard brief. Gives me a very quick look at population, hazard exposure area, as well as the smart alert notification area, meaning this is the area where anyone within that would have been notified. And a few other issues just in terms of some multi-hazard resilience. This was our old one. We still run this. It's a good simple look at it. I am going to hope that I've got a event brief. Green is always good. One of the things with an automated system is we build it for lots of different possibilities, and every so often it doesn't generate a thing the way we expected, and then we find out, yeah, it did what it was supposed to. It just didn't do what was most convenient at that moment. So with here, I've got, there's a practical aspect to this, which is for disaster managers in countries affected by this, they're able to pull this up and generate it as a one page or as a part of a slide deck if they need to get quick answers to folks who are asking them questions. In this case, though, what's nice about it is this is actually a little more dynamic. I can zoom in, I can take some of these layers off, and that still gives me but a profile look. I've got, I can also look at overall risk. Here I am in both Indonesia and Papua New Guinea. And some of these will give me some more information if I generate some full reports on it. Organizations and activities that may be related to this. So walking through this, it gives me, sort of several things I can look at. I also have, this is my basic situational awareness brief, which is the automated single page report. Now this is static, not dynamic. But for disasters that go on for several days, I'll start to see a list of these every 8 hours or so. So I'm getting both a larger view of my rainfall, a close-up view of the landslide severities, and then broken out, as well as some affected infrastructure or what we think of as the lifelines. This is a static shot. Again, it's easy enough to turn into a PDF. What we've found, and one of the things that makes disaster aware its main purpose, is disasters are as much about communication as they are about response and operation. And we find that a lot of the folks that are leading a disaster also have that obligation to try and get best information, both downstream and up to other folks that are decision makers higher up. And so a lot of what we try and do is save them a little bit of that time and searching around, give them some consistency by automatically producing a product and continuing to update it so that they're not spending a lot of time trying to pull that together. Put something in their hands quickly, allow them to get back to the focus of what they're trying to do in managing the event. Going back over some of the other things that we can do within the system, as I showed you some of the layers. One of the things I was also taking advantage of is I created a bookmark for this one, which means that it's got a set number of layers, a set extent. That helps me to click on it quickly. I don't have to keep recreating it every time I log in to be looking at the same event. I could also create a bookmark that gives me my whole country and zooms in and the layers that I care about. So that makes things a little bit easier in that regard. I'm looking just to see if I've got other things. I did want to just show one other aspect of this, and that is right now I've filtered entirely on just landslides. But thanks to the work we do with the other NASA teams, I'm going to add floods in, and since these are global floods in this area, what we'll see is these are all the landslides are produced by LASA, the floods are produced by the NASA model of models, and we can see some coincidence of these so that we also know, for instance, in here we're dealing both with a landslide up there, but I've also got a flood. That flood also has products, situational reports. I'm going to back that guy up just a little bit and go into here and see. Now, this is what I was referring to earlier, is I've got sort of a longitudinal look from as many as 15, 17 days ago of how this has evolved over time. But on each of these, I've got some basic critical factors, some ports, seaports, and hospitals that might be affected. This is, as I mentioned, this is a static report, but as time goes on, we can modify these reports or create additional reports this is the easy one to get to, but within the system itself, there's also a way. I don't want to go into the too much of the details on it, but there's a way to pull layers together, get a view of it, and then click on a button to create basically a snapshot that will give you a PDF of that view with a little bit of a border, so you can actually create on the fly the view that you're looking at as you're doing analysis and those kinds of things. With that, I'm going to take another pause just to see if there's any questions on some of that situational awareness stuff.
I don't see any raised hand.
Okay. Then I'll give the last. Go ahead. Sorry.
No, you please.
Oh, okay.
Continue.
When we look at this exposure, one of the, I mean, you'll see that on there where it talks about the exposed population. What we're really talking about is, and this one's for the flood, so I'm going to go ahead and there. So for that flood, what it's doing is we have another system called AIM that actually gives us population and population density. And that population density is unique to each country, as well as the distribution of population within that country, so that so therefore, when we see sort of the population, households, and such, that's generated from the intersection of this exposure with our impact modeling map of population needs infrastructures, and we're also coming up at that point to some level of economic impact. On this one, I'm going to go back on over to Event Brief, and it will tell you not just how many folks are impacted, but also the distribution demographically. Again, this is unique to Indonesia and Papua New Guinea, and the amount of exposed capital infrastructure that may be affected by it. Probably more so with floods and other things with landslide. What we're really talking about is population that could potentially be affected by the loss of lifelines, interruption of transportation, and other things due to a landslide hitting some major transportation artery or something along those lines. So what we're really talking about is the number of people that might be affected in some way from this landslide. That covers all the main points. As you can see over here, we've got I'll pull that guy and go into here. So I've got very specific layers, data layers that relate to landslide, as well as ones that relate to flood. I could turn on different combinations to give me a better picture. And I have that with each. We also, in dealing with response, we've got some local layers that we'll put in, or regional data that goes in. You can see some of that. When we've done interactions with specific countries, we get country data, and we use this system as well to do national analysis of risk, retro analysis on response to particular disasters, after action kind of analysis of all the stuff that gathers. For some large occurrences, I showed you just a few products that were associated with a recent flood, the product that's associated with the landslide. But for disasters that wind up, occurring and stretching out for a while, you can get dozens, if not, hundreds of points of data that are then connected to that and live on with that hazard down the road. So after that hazard is expired, after the disaster is over, the response is completed, we can go back into this system and filter on past times and regions and look for what happened there last year, the year before, within some sort of fixed time frame. And I believe that those and I'm going to do the one thing, you know, they always tell you not to do in giving it. So I think this will work for me, but I didn't test it out. And I'm looking for an expired one here, and I go up. I've got it's expired, so it's gray, and I'm looking to see, and I've got the product that was generated for it. So that means I can go back, look historically at what the system had said were hazards. And this becomes very valuable when you then interface that with the disasters that wound up occurring from the predicted hazards, and able to sort of combine a lot of different data. Oh, sorry, Michelle.
Yeah, Greg. Thank you very much for this extremely interesting presentation, and also showing us this very dynamic and interesting tool that you're using. I'm wondering if I understand well that all this platform, the many models that you have inside, they're all for forecasting and assigning a level of hazard and risk. But are you also within your organization collecting data on past events? And if so, are they also available in your platform now to match with what you have forecasted?
That's a very good question. We do have various iterations of historical data, some that we brought in from other sources. We have all of the information we've got from when the system went live. For landslides, we would only have it would only go as far back as last summer in terms of what hazards we've generated. But we do have historical data, and we're always on the lookout as well for additional historical data, since it's useful, extremely useful. And I'm just trying to think through. We use some of that. I think in the event brief that I was showing you, it actually is supposed to show. Here we go. Down here, I've got event history that says in that area, similar landslides that might have occurred. So I've got some historical ones that predate the hazards that got created as sort of a timeline look.
So you're saying that you essentially you were putting, now you're talking about events that are real events, not right. the event that you were showing as the forecast, right. Like okay.
Yeah, the ones from 2021 are from a historical database. I think these are previous hazards that had occurred there. So, oh no, I'm sorry. Yeah, I do have. I've got the data information. So these are the ongoing actual events that occurred.
Okay, thank you. And then, what can I ask you something else?
Sure.
If because I understood that your platform is very flexible. Of course, you already said that you can add local data in terms of layers right. of information, GIS, to have those at hand when you need them. Okay. And I understand that they are also flexible in importing models that could run and be operated to generate the forecast. Right. I'm wondering if you have examples of cooperations with authorities that work at a level that is much smaller than the global scale. Like you are basically, I understand well in Hawaii, whether maybe in your own area, in other areas, you've been cooperating with some local regional authorities that are indeed putting some models there that are more local.
We actually do a very small portion of what we do now is related to Hawaii. The only things Hawaii specific is high winds and surf conditions. All of the rest of the data that we're dealing with, as much as possible, is global and normally from freely available sources. I don't know that there's much that we purchase. We do work with a company that does hurricane modeling and prediction, so that when we're displaying hurricane models, we get it from them, but we also get it from NOAA and from other places. Most of the data we use, very little bit of it comes from private sector. Most of it is freely available from NASA, government sources, international sources, Copernicus, other places, for what we bring in. And in all cases, I mean, our center now, we used to go by Pacific Disaster Center. Now we call ourselves PDC Global. So, and we spend more time, we've got teams that go around the world, work closely with specific governments. And as one of the folks mentioned, they're working with Alex. We work with the humanitarian aid and assistance from the different military commands that try and assist out in the different zones. Really, one of the best things about the collaboration with NASA for both landslide and flood is both of those filled a gap that we had where we did not have good data for flood outside of the United States, where we've got stream gauges and such. Now we've at least got a predictive model. And same with landslides. With landslides, primarily before LASA, what we're doing was reporting when a landslide would occur. So we were, a day removed because we'd see it when we're looking through press reports. So trying to move more into the forecasting, it's got obviously pluses and minuses. The pluses, we get a lot more data to be able to look at. The minuses, certainty, it's more stochastic than it is predictive.
Greg, is there any
very
way
much.
that the
Thank you.
user can tell which is which is an automated hazard and which is a manual hazard?
Yes, there is. It's not an immediately obvious one, but it sort of is. So, for instance, when I go and look at floods here, for instance, and I'll get a landslides, you can see our source here is the National Weather Service. Moving down to Mexico, our source is NASA, the model of models. All of our landslides, for the most part now, I was about to say something that's not true. We do have some manually entered ones, and I'm going to look just to see. So, for instance, this one, I'm just double checking to see. Nope, that's also LASA. I'm looking for. Give me one moment. What I'm actually looking to see is advisory. Nope, don't get any of those. I'm going to go back further just to see if I can bring one up. There we go. Nope, there's floods. I don't want floods. Sorry. Give me one moment. Take flood out of there because I just want to deal with landslide for right now. And I'm going to go back even further because I know we've got, I thought we had some in the system. One last try here. This, and I'll do to go back further. Oh, I know we have had after action reports, and I thought that they came in as that advisory level, but I'm not seeing any of them at this point. Making sure, I'm trying to make sure that I've actually clicked something. Landslide. There we go. Yeah. But we do have a team that looks and scours sort of press reports. So if something comes through, whether it's flood list for floods or press reports of landslides. If we don't have them in the system, they get added in at that point. And what you would see then is you would see in the description, it wouldn't say the LASA model. It would indicate where the source was from, which is a different source. It wouldn't be obvious when you're just looking at the system, just up on the icons, but it would be once you're actually looking at it. There was one other question about just the forecast versus actual. We do have a couple that can't be forecast. Earthquakes and volcanoes. We've got the USGS gives us a report of earthquakes on occurrence. We get probably 30 or 40 every hour of various different magnitudes. With volcanoes, we use the VAC system of aviation monitoring for ash cloud. But those are specifically after action. For forest fires or wildfires rather, we don't have a wildfire predictor, but we do have remote sensing that we use from the NASA FIRM satellites. So in that case, that's spotting and discerning as an actual event already, and it helps us get a perimeter for that. So some near time, some real time, some after action, and some forecast. I think that's all I've got.
Oh, thank you, Greg. Yeah, we have 3 minutes left from this call, but my last question is, what level of service you offer for the institutions of the general public, and also how the people can access to these features?
It's simply a matter of getting a login for most systems that have got, or for most organizations. National organizations, nonprofits, those are easy enough to get to request an access to the system. And that's the system that you would get access to is the very one I'm using right now. There are, for the most part, users have access to all the things I'm showing. I also have some additional capabilities. Well, we have some folks that work for PDC that are able to manually enter a hazard or manually adjust it. But that's a specific trained group. I don't think I'm actually allowed to do that anymore. I think they figured out that I'm better at presentations than adding things into the system. So they have smarter folks.
Right. Thank you.